After becoming chair 2 years ago, Professor Kathy Cash has proceeded to apply her wonderful talents in research and teaching to our administration, and she's taken our department into all kinds of new wonderful things, and one of them is this. Her leadership is distinguished not only by great ideas, but by implementation. That's the big deal, carrying it out. And today's big celebration is an example. It's come to pass only because of her. So thank you, Kathy, and thank you for introducing the celebration.
So very little, if any of that was true. I especially cannot take credit for this first ever festival of decade birthdays. It was Bob and Phil who, in contemplating our tradition of celebrating decade birthdays, who realized that it was 9 of our over 40 faculty and emeriti who have a decade birthday this year. And so this celebration is their idea and their implementation down to their instructions to me about what I should be doing. But we did have to just do something special, and so we are. By the way, they tell me that there was a 0.1% probability for this to occur, and that doesn't include the fact that this is the 110th year of Albert Michelson's birth. So here is what we are doing. For each of our honorees, we have asked other faculty to give a little speech on their behalf about some interesting things in their past. By the way, when you do that, you should come and stand here and hold both these microphones. We could talk for an hour at least about each of our esteemed decadians, but for today, each speech will be limited to 3 minutes or so. Bob will announce each orator, starting with a long-distance phone call to Glenn Starkman, who is on sabbatical in Geneva, Switzerland. At the end of each testimonial, the honoree will stand to be acknowledged, but won't be allowed to say anything. And then we'll go on to the next decadian. Let the fun begin.
So Glenn Starkman leads a not-so-secret double life. In one life, he's a distinguished cosmologist, and in another life, he works tirelessly to make this university a better place and to promote public engagement with science. Considering all that he does in his 2 lives, I feel like we should really be celebrating his 100th birthday and not, and not merely the 50th. Glenn grew up in Toronto. He attended the University of Toronto, where he got a BSc in mathematics and physics and astronomy. Glenn has a PhD in physics from Stanford, and he did postdoctoral work at the Institute for Advanced Study and CETA in Toronto. After that, we were fortunate to bring him here to join our faculty. Among other recognitions, Glenn received a National Science Foundation Career Award as a junior faculty member. He was a Guggenheim Fellow. He is a Fellow of the American Physical Society. And more recently, he won the Dieckhoff Award for graduate mentoring. Glenn has many wonderful scientific accomplishments. He's done pioneering work on using occultation to look for extrasolar planets, on modified gravity as an alternative for dark matter and dark energy, on observing the topology of the universe, on interacting dark matter, on observing black holes and strong gravity effects of the Large Hadron Collider. He's raised provocative questions about whether the cosmic microwave background on large angular scales is cosmic. And last year, he invented a new kind of star, electroweak stars, and he's now working on looking for them. There are 2 common themes to Glenn's body of work. First, the amazing breadth and depth of the work. Second, the problems are chosen based on their importance and not on what is currently fashionable. At its best, Glenn's work is so next year. Among his efforts to make this university a better place, Glenn has served as chair of the Faculty Senate, and some years ago he devoted a great deal of effort to a commission that made many prescient recommendations to improve the quality of undergraduate life here, and some of these have come to pass. Glenn directs CIRCA and the New Institute for the Science of Origins, which has partners ranging from the local PBS station to the Cleveland Museum of Natural History, and a mission to advance and promote the scientific understanding of origins from the Big Bang to human origins. Glenn's work has received major media coverage, and he's an energetic popularizer of science with 3 Scientific American cover articles to his credit. I remember once seeing an article in the New Yorker in which John Updike commented on Glenn's work. If John Updike reads you rather than the other way around, you've got to be doing something right. Okay. Yeah. That's true. Yeah. Okay. Well, impressive that these accomplishments are, I'm sure that Glenn's best work lies ahead of him. Anyone who's seen Glenn at work would agree that Glenn shares this conviction. I'm glad to count Glenn and his wonderful family, Debbie, Nathaniel, and Ariana, among my friends in Cleveland. When I first came here, I narrowly missed Glenn's 33 1/3 birthday celebration. I kept hearing from everyone that it was the best party ever, and I was quite sorry to have missed it. Now today we're celebrating Glenn's 50th birthday, and this time Glenn is missing it. But I'm sure there'll be many more occasions for us to celebrate in the future. So Glenn, I look forward to having you as a colleague for many years to come. Thank you.
Thank you, Harsh. Look forward to seeing everybody soon. Happy birthday, everybody.
So Corbin is turning the big 5-0 this year, as with Glenn, and we're lucky to have him here at Case, both for the excellence of his research program, but also for his deep engagement with students, and also for the other large burdens that he shoulders on our behalfs. Up here you see a sort of collage of some of Corbin's good works, which I'll refer to in a little while. Corbin comes with quite a pedigree. He was an undergraduate at MIT. He was a PhD from Harvard and a postdoc and junior faculty member at the University of Chicago, and he joined us in 2001. And I joined us in 2002, and Corbin being here actually was quite a piece of the puzzle for me, or Corbin being on his way here, I should say. I remember talking to him on the phone when I was trying to make my decision. So it was great to have both Dan and Corbin on his way here doing particle astrophysics to help me want to come here. Corbin, though, has always known that he wanted to do physics and astronomy, since he was quite young, at least. But we did almost lose him at one point when he took a great behavioral psychology course at MIT. And he says that was just an awesome course, and he thought about switching, but he never found time to take a second course in behavioral psychology. Thank goodness they keep their undergraduates as busy as we do ours. So, but perhaps this interest in behavioral psychology explains a little bit why Corbin can keep on such an even keel throughout the chaos of our profession. He is a very solid and stable influence in our department, I believe. So he did his PhD on a balloon-borne X-ray telescope called Excite. And so that's shown here, down here in the bottom right. I do ballooning. Corbin did ballooning, but he flew this experiment twice from the outback of Australia and once from glamorous Fort Sumner, New Mexico, and was thereby cured of the ballooning bug forever, apparently. So that was sad, but he moved on to cosmic ray physics rather than X-ray astronomy as a postdoc at University of Chicago, where he worked on the Cherenkov air shower array, or CASA MIA, as he called it, the thing in the upper right there, which was out in Utah. So his programs basically got too big to fly, and so he had to do them on the ground. And then he worked on Stacy, which was, and was still working on that when he came to Case, down here at the bottom right. And this is a really cool thing where they already had this, I need to pick all this up. This thing right here is a bunch of solar concentrators that would focus light from the sun up to this tower here. And it was a way of trying to make solar thermal power. But he and others came up with this idea of using those at night, when they were not busy making solar thermal power, to actually look at gamma rays and do gamma ray astronomy with those. So that was a neat project. And when asked how he chooses his projects, Corbin says that he looks for broken projects and tries to make them work. I hope that is not how he chose to come here. That is, though, how he joined his current main project, Auger, which is the world's largest and highest energy cosmic ray detector. located in Brazil. So you can't take a picture of it. It's too big. So you can make a map of it and take a picture of Corbin with some tiny piece of it. But what he did there was he fixed the timing problem associated with all the different stations and got via the GPS clocks and testing 2,000 GPS clocks down in the basement here so that they could actually tag events with 12 nanosecond precision. And he tells me now that they're doing this much better. They can do it to 3 nanoseconds or something like that, which is quite remarkable. But aside from research, one thing that's very special about Corbin, and which I feel embodies much of what we're about here at CWRU, is his passion for undergraduates. He's a Whitke Award winner. He has historically had a very high level of undergraduate participation in his research with 4 or 5 students working with him in the lab during the typical summer. He was the first person, I believe, to use clickers here at CASE, certainly on a large scale, the voting things for peer instruction in large lectures. And he's remarkable for his actual love for teaching large lectures in introductory classes. In his words, he loves it that, and I quote him here, when the students go from I don't get it to I get it, you almost get a sunburn from the light bulb going off. So that I think shows you how he feels about instruction and education. Thankfully, Corbin has several more decade birthdays ahead with us, we hope. We celebrate his enthusiasm and his accomplishments. We thank him for his thankless service in recent years as the associate chair of our department and as the graduate program director. And we should learn and take heart from his personal motto, or at least I'm labeling it as personal motto, and I quote him here, "Every time you do something, do it slightly less wrong." Thank you, and happy birthday, Corbin.
As probably a lot of you know that Dan and I go way back, so my comments are probably going to be a little more personal. But to talk about Dan's background, he was at the University of Chicago as an undergrad. Then he was at this place called Princeton as a grad student, and then he was at Caltech as a postdoc. And he met worked for some fairly illustrious people along the way. Stu Smith was his graduate advisor, who was later became the head of SLAC. And Caltech, he worked with Barry Barish, who was the head of the ILC. I met him when he had just followed his wife, Chantal, to Berkeley, right when I was finishing my PhD, and he arrived. And he sort of wisely, well, not only did he follow Chantal, following what I always think of as like sort of a whirlwind courtship. He got married right away. He came to Berkeley, and he switched from particle physics to dark matter, sort of in the early days. I think it showed good taste. He was the fellow, there was a Center for Particle Astrophysics, and he was the fellow. So he joined the group I was part of as a postdoc. Shared office with him for a couple of years at the time. You get to know people when they do that. If you're good friends with him, he can show you this photo of what he used to look like. Not even then, but earlier. He was a deadhead. And he looked a little bit like, this is dated reference, but the guy from Welcome Back, Kotter, the big mustache. And it was also interesting, he'd recently gotten married. He did, and then I got married about the same time, and then turns out they have a child, and my older son and M. Degowski's daughter, not only are all students together at Heights High now, they were all born in the same hospital in Berkeley. I remember one of the early encounters I had with them working together, our group always had much, much bigger plans than we could carry out in terms of time schedule. And we had this huge, complicated piece of apparatus that he was instrumental in help get running and building. But then after that, we had to move it from Berkeley to Stanford. And I remember he sat down with this other guy, and they sketched out, and they said, after thinking a lot, they said, it'll take about a year to move. And most of our schedules consisted of saying something will take 3 weeks, and it would take 3 years, or something like that. And they actually, I kind of was watching them do this, and they're planning, and then, by God, it took them a year to move it. Almost, plus or minus like a month. And I was just like stunned. Like, how could you think that through and accomplish that? I was very amazed. He's wonderful to work with. Loves building things. I remember an early time we were at a party, and I saw him over with my son, who was tiny at the time, and he was working on some little thing, and he made this wonderful little paper construction that he showed Gabriel how to build, which was with a flat piece of paper, and he drew some lines on it and cut it out and folded it into this little truck. And just, he has a real talent for doing things like that. So then one day, this sort of funny guy showed up in our office and was talking to Dan, and his name was Lawrence Krauss. And so Dan left Berkeley and came to Case, and I guess had a strong role in setting up the particle astrophysics group here. And then this was the CDMS dark matter experiment, which for about a decade was the leading dark matter experiment. And he had a huge, very important role in that. I think he was, real leader in that. Eventually as co-spokesperson of Super CDMS. In 2004, he recruited me here, and I got to start working with him again, which was great. In fact, we joined forces in 2008. He joined the Lux experiment, which had started. I remember he said later, he told me much later, that when he joined, he'd actually sat down and they were wondering, I wonder if it's all done. Is there going to be some role for us? In point of fact, we were just drowning, and I think he bailed us out. So he said, plenty of work to do. We've been very busy since then. Those of you who know Dan know that he's, often played amazing role sort of as a mentor to people. And I certainly have felt that. He's had a set of students who've done very well. I remember when I was myself struggling with all the cantankerous characters in the dark matter field, there was a point in time before I came here, when I had his office number memorized, because I'd call him up often and say, how do I deal with this? And those are always looked forward to those phone calls. But he's not all warm and fuzzy. He has some steel and judgment. So there was this incident about a year or two ago when he was on a panel, the HEPAP advisory panel, and it's one of these panels, and they're supposed to rubber stamp some, conclusion they've come to. And the conclusion they came to was that the Tevatron should run a bit longer. And it didn't seem to make a lot of sense to Dan, in fact, to a lot of people. And so there was a 15-to-1 vote for that recommendation. There was one holdout. It was Dan. And afterwards, several people who knew it really shouldn't have happened came up and thanked him afterwards. And it was the right call. So I'd like to conclude is trying to think, well, what role does Dan play? So for right now in our experiment Lux, Dan's not wearing some sort of management hat with the title. I mean, I guess he finished with that after being chair. Didn't want a title like that. But he actually plays an incredibly important role. And I think the right model is, if you remember The Godfather, Robert Duvall is the consigliere. That's how I think of Dan.
We're lucky to have Phil Taylor give a perspective pertaining to Chuck Rosenblatt.
Some of us in physics spend a lot of time writing proposals. Write proposals, send them off to the NSF, DOE, NASA, wherever. And we sometimes get some of them funded. There's a 10 to 20% probability for that. Chuck is different. Chuck just works away there in his lab, and then when the money starts running a bit low, he just dashes off a proposal and waits for the check to arrive. And he has an extraordinary success rate. It's approaching 70% success rate on all the proposals he writes. And he's had continuous single investigator funding from the NSF for all the time he's been here and for time before that. It's absolutely an amazing research record. It's really unequal. He has a number of natural advantages that really help him in this success. He has a great physical insight, and he's great at getting new ideas. But the one particular advantage he has is that he wakes up at 5 a.m. every morning. and he gets in here by 7. And so there's the advantages, but he does have a handicap, and it's a serious handicap. He's a very, very generous person. He gives credit to others for minor things in an extremely generous way. In the 8-year period from 1995 to 2003, our names appear together on 16 papers. And I have to say that Chuck did the great majority of the work. It's typically his generosity. He's worked on a wide variety of problems in soft matter and is a world authority on liquid crystals. He's also used his great ingenuity to provide insights into the motion of fluids. And that's what I'd like to talk about in the little time I have left. Now, we probably all recall that if you could invent an anti-gravity machine, that would be a vitally important thing. And in fact, H.G. Wells described a material called cavorite that was an anti-gravity shield. Well, Chuck does things a little differently. He uses a magnetic field to suck things up. So if you see those magnets there and imagine, say, a liquid in that yellow tube, he has the ability to defy gravity by imposing that magnetic field. As an example, for instance, he can make a heavy fluid rest on top of a light fluid. And so if you could imagine that could, for instance, be cold, dry air over hot, humid air. And what then happens is it's unstable, of course, and you get something like hurricanes, tornadoes, and things like that. In the particular case that he's working on, he just has in the lab his heavy fluid above a light fluid and watches the instabilities that happen. And here's a movie showing some of that. Look at the top. That light line there is the heavy liquid, and the dark stuff below is the light liquid. And you see this interesting instability, all these mushrooms form, all this chaotic stuff. Now that's a pretty messy thing to study. So Chuck had the great idea of putting some order into this by imposing a magnetic field. You see that wavy line at the top? That's a steel wire that's magnetic. And so that really triggers the thing into having its instability in an ordered way. So when we turn that one on, we can see that it forms exactly 6 loops when that happens. And that's great. That allows him to analyze things in much more detail. And for instance, you can see all these charts here showing how you can now get some real physics out of what seemed like a very chaotic thing. And so that's my tribute to Chuck, who is the master of anti-gravity. And the question I ask is, what will he come up with next?
We're lucky to have Jia Shan launch a tribute on behalf of Ken Singer.
So a few years ago, I met this famous young physicist, this guy, when I came to Case Western for a job interview. And ever since, I've had the fortune to call him a colleague, a collaborator, a mentor, and a friend. Professor Ken Singer group grew up a few miles from here, and he went to the Ohio State University to get a BS in physics, and then his PhD in physics from University of Pennsylvania. He started his career as a member of a technical staff, and later a distinguished member of technical staff at AT&T Bell Labs in Princeton, New Jersey. But he missed the Cleveland weather so much. In 1990, he was persuaded to join this department at Case Western. So actually the first time when I heard of Ken and Ken's work should be traced back when I was still an undergraduate studying nonlinear optics in Moscow, Russia. Ken and his co-workers at UPenn and later at Bell Labs are considered the kings of the nonlinear optics in organic materials. So nonlinear optics is not experience of our everyday life. Nothing changes for this type of illumination. But if you can increase the intensity of illumination, for example, laser light, you can see that the optical properties of material changes with intensity and other characteristics of light. So in early 80s, Ken and his co-workers applied nonlinear optics to study organic materials for the first time and actually started the field, which now is a very large interdisciplinary area. Some of his work using electrical field to induce orientation of dipolar molecules in liquids and in polymers remain some of the most cited papers in optics. So we all know that Ken is a person of many interests and talents. I don't know whether he sings well, as his name suggests. But I heard he's an excellent piano student. He told me. So Ken loves nonlinear optics, but he also loves adventures. So over the years, he's made significant scientific contributions to a very broad range of topics. His latest two involves organic semiconductors at the nanostructured scale for next generation photovoltaic applications, and also multi-layer polymer structures for photonics, optoelectronics, and data storage applications. Ken has this tremendous skills in management, and he uses his managerial skills very, very well to serve this department, this university, and our community. Just to name a few, he is the founding director of the engineering physics program. He, together with Chuck, built the Moore Labs. The whole list is very long. So he served as the associate editor of the Journal of Optical Society of America. Right now, he is a platform leader and an associate director of the Center for Layered Polymeric Structure Systems, funded by the National Science Foundation. So anyway, the whole list is very long, and I only have 3 minutes. So I often wonder, how a single person can achieve so much, not just in one dimension, but in multiple dimensions. So that still bothers me. 60, also known as stems and branches in Chinese, is a new cycle. So I believe, like me, we all expect to see new chapters from this exciting, interesting book from Ken in the decades to come. So to Ken, a distinguished scholar, a lawyer, and a selfless citizen of this community, and an inspiring mentor for young faculty like myself. I still call myself young. Allow me. Students and the new generations to come. Happy birthday and congratulations, Ken.
Thank you, Gary, for coming back. Gary couldn't help. He had to go to his lab class to help make sure that everybody was okay. We're lucky again also to have Dan Shearson give his personal role in the saga of Gary Chotiner.
Well, I'm indeed very pleased to have the opportunity to talk to you for 3 minutes about Gary Chotiner. In fact, among the things that Kathy Cash has done is a new program about affirmative actions for science, so now they invited a chemist to talk in front of an audience of physicists, which is indeed very good. Well, Gary was born and raised in Pittsburgh and received his PhD from University of Maryland some time ago. I wasn't aware that he had turned 50 and all of a sudden he's turning a different decade. So I met Gary in the back of a limo in the New York City airport, and don't get the impression that we were applying for some high-paying job in a banking institution or we were being considered for some movie in Hollywood East Coast. In fact, both of us have been awarded an IBM Faculty Development Award, and we went there to claim the award. And during that conversation, we decided to just join forces with our setup funds. So each of us had a few $100s. I will never forgive him because he had a little bit more than I did in trying to build an ultra-high vacuum chamber. And in fact, this venture from a conversation went into a nice history. And in fact, by now we may have built jointly about 5 ultra-high vacuum chambers. So we proceeded to develop a new field that combined physics and chemistry, which has to do with interfacial science. And that culminated in an experiment that Gary and I conceived, which is to do electrochemistry at 10 to the minus 10 torr. I'm aware that torr is not an SI unit, so please forgive me. So the last 2.5 decades, Gary and I have advised 8 graduate students, which are joined, some of them in chemistry, some of them in physics. And there is one particular one that went on to join a very prestigious department in a very prestigious university, and that is Steve Appel, who is now professor in biomedical engineering here at Case Western Reserve. And we are very proud of that. Speaking of students, it'll be a real crime if I didn't add the tremendous role that Gary has played in the university, both in teaching and administration. And besides, he's been director of the undergraduate studies in the physics department and serving on countless department committees. Gary is enormously respected, and he is the past chair of the faculty senate. And Bob Brown tells me that he stopped counting after he got to 100 university and college committee years, which Gary has served. So far, Gary and I have co-authored more than 100 papers in refereed journals, and I think that sets up a record of collaborations between physics and chemistry, at least in this institution. But Gary, as all of you know, has a passion in trying to combine 3 different things. And that is surface science, writing, and Porsche automobiles. And so, so Gary's main dream was, will I ever be able to put a single piece of Porsche inside the USB so that I can do my surface science? And in fact, I have to tell you, Gary, that thanks to all the students of our groups, they managed to get you a single crystal Porsche that is now installed in your USB chamber. So, in closing, collaborating with Gary has been a tremendous experience from a scientific viewpoint, but most of all, it has been a tremendous experience on a personal basis. I have enjoyed these 20 plus years, more like 30 minus years of interaction, and I look forward to another decade. So Gary, happy birthday.
We're in for a treat. David Farrell is going to tell us the legend of Arnie Dahm.
At occasions of this sort, at the ancient universities of Oxford and Cambridge in England, the orations are generally given in Latin. Now, our university is fairly ancient, so I decided to deliver Arne's oration in Latin. Here goes. Ti quidem in generis humani, damus electronicus localicus, quantissum fluidus, summa eloquentia, summa eruditione, summa, and so on and so forth. Unfortunately, we're only allowed 3 minutes. I tried to distill the Latin down, but failed. So, with apologies, particularly to Cyrus, our departmental classicist, I must continue in English. Arne started his graduate work in liquid helium over half a century ago. That is, before our 3 quindecadians were even born. Now, in physics, and his most recent work, also on liquid helium, is currently under review. Now, in physics, this is as close as we can get to eternal life, right? Half a century of this. How has the fellow stayed so productive for so long in a single field, liquid helium? Well, when we're looking for problems to work on, students generally try to choose one that is a balance of fundamental and practical interest. Arne's career, in my judgment, is a testament to the fact that it also helps to choose a difficult problem, a really difficult problem, one that will be around for a while. He has led the way in many advances in liquid helium, and I really don't have in the last minute time to do that because I am adhering to my 3 minutes. Do you notice, Bob? But liquid, anyway, I tried to allude to them in my Latin text, but liquid helium itself still retains its fascination with many puzzles and challenges. Now, if you'll forgive me in my last minute, I'll set physics aside a little and finish on a personal note. I asked my octodecadian the following question in preparing for today. I asked him, what has been the most rewarding aspect of your activities in the lab? Aside of honors, grants, publications, citations, all those good things, what has been the most rewarding aspect? And he told me that it was, for him, engaging with students, figuring out with them the best way forward, and sharing with them the thrill of discovery. Those were his words. His lab was next to mine for many years. And while he was speaking, once again I could hear those excited students of his, folks like Ravi Mehrotra, George Seil Halaz, and Hongwen Jiang, which perhaps some people here still remember. All 3 of them are now distinguished scientists having wonderful careers of their own. And in my own mind, in my mind's eye at least, I can see them here again with us, raising their voices to sing praises to Arne. I can just see them here with us. So I'll conclude by simply adding my voice to theirs, and on behalf of myself and my wife, Bobby, thank Arne and his wife, Susan, for blessing our lives with their friendship. Happy birthday, Arne.
The Chronicles of Keith Robinson, and Margie, thank you for making it. She worked very hard to get a change in her plane so she could make it. The Chronicles of Keith Robinson, as related by the inimitable Bill Fickinger.
Quare me repulisti et quare tristis in cedo dum affligit me inimicis. I was an altar boy. Keith Robinson was born in Truro, Nova Scotia, where he and his little brother helped out in their mom's friendly tea house. It was exciting when he moved down to Halifax to attend college at Dalhousie. Keith is not really his first name. That's so secret that D. Keith Robinson's email address is KXR2. But the noble name Keith seemed more appropriate at Cambridge University, where he began his doctoral studies. As if Cambridge were not sufficiently impressive on his CD, Keith switched to Oxford University, where he completed his DPhil in 1960. His research was on those literally strange nuclei, which house a hyperon as a stand-in for one of the nucleons. The practical applications of hypernuclei are yet to be uncovered. Moving back across the ocean to Brookhaven Lab, Keith tackled the more mundane interactions of two BeV protons. We used to say BeV in those days. The Salant group at Brookhaven had been chosen to get all the film from a major run of the 20-inch hydrogen bubble chamber at the Cosmotron Accelerator. Keith was the lead man in the data analysis, which included supervising a team of Long Island housewives who searched the film for interesting collisions and who transferred the coordinates of the curving tracks to holes in punch cards. Software for the subsequent analysis could identify the players in the individual collisions. Putting it all together was Keith's job. Soon afterwards, Dr. Salant was visited by a Yale professor who had come to Brookhaven to ask a favor. It seems his student had been working for a year helping to build a beam separator for use in a pi meson experiment. Just as they were about to begin the run, the pole face windings of the Cosmotron burned up, delaying any operation for at least a year. Might dear Dr. Salant share his film with Yale, so this dedicated graduate student might graduate on schedule. Much to young Dr. Robinson's chagrin, half the film was flown across Long Island Sound to New Haven, and a collaboration that would last 40 years would begin. You might have guessed who that Yale student was. After I graduated, I spent a half-dozen years in postdoc jobs before I got a call from Keith, who had joined the Western Reserve Department a year earlier. Even though the newly merged Case and Reserve Physics departments had about 50 faculty members, there was an opening for another particle person. A big NSF grant had been approved. Would I like to join him in Cleveland and get in on the fun? We had labs for our measuring machines in Millis and then in Wickenden, and analyzed bubble chamber film from Brookhaven and Argonne for about 15 years. Later, we switched to counterphysics, building wires in-house. For another dozen years, we collaborated with friends at Carnegie Mellon, Syracuse, Boston University, Brookhaven, publishing on K-meson and anti-proton interactions. Keith's special talents in data reduction and error analysis led to an invitation by McGraw-Hill Publishers to create an expanded and revised edition of former Case professor Phil Bevington's widely successful book. This work continues to be a popular guide to experimenters in all fields of science. Working with Keith has always been fun, as we contributed our modest share of numbers to the standard model. It was a pleasure to work with such a talented and easygoing friend. Happy birthday, Keith.
Well, I'm excited to talk about a mentor of mine and of Cyrus. Kenneth Kowalski will be, we'll have a proclamation about Ken Kowalski by Cyrus Taylor.
I can't tell you how pleased I am to have this opportunity to talk about Ken. Ken's been a friend, colleague, and mentor of mine ever since I came to Case Western Reserve University almost a quarter century ago, which is actually a very scary number for me. Couple of highlights of just key points on the Vita. He was born in Chicago 8 decades ago. He got his Bachelor's of Science degree from Illinois Institute of Technology in 1954, and then spent 3 years as a research scientist at the National Advisory Committee on Aeronautics, now NASA, Lewis, now Glenn, Research Center, where he worked on problems of fluid dynamics and supersonic flow. He then went to Brown University, where he completed his PhD with a thesis on the two-body formulation of high-energy nuclear scattering problems, opening what was a fruitful period of investigation for him for actually the next few decades. In 1962, in other words, 50 years ago, he came to Case as a research associate and started on the faculty a year later. So, he's been here at the institution as long as the youngest of the honorees today have been alive. He was promoted to associate professor 4 years later. Ken will correct me if I get any of this wrong, I hope. But 1970 became executive officer of the recently combined physics departments, and a year later became chairman of the department, where he served for 6 years during a period which must have been just extremely difficult. And then in 1973 was promoted to full professor. His research, the core of it, the bulk of it, is a wonderfully talented mathematical physicist that's done pioneering work in a really broad spectrum of areas, including the original supersonic flow problems, working on bounds on cross-sections at high energy, three-particle scattering, work that he did with Bob on vanishing of radiation cross-sections, so-called radiation zeros and high-energy scattering that later were wonderfully confirmed, in data coming out of the Tevatron. Field theories at finite temperature, doing some of the pioneering work there. Nonlinear optics, correctly writing the Feynman rules for Majorana particles. And work with me on a putative phenomena called disoriented chiral condensates. And I'll come back to some of that in a minute or so. In addition to his service as chair, he's done great service, I think, to the department and the profession, including in 1987, co-chairing with Bill Fickinger, the 1987 Modern Physics in America Symposium on the Centennial of the Michelson-Morley experiment. He ran a workshop on thermal field theories just after I came and edited the proceedings on that, which I think was wonderfully influential. And published a book with collaborator Adhikari on dynamical collision theory that in fact pulled together much of his work on scattering theory up to that point. Ken's also renowned as a teacher, where he has extremely high standards and often has, I think, just a perfect pitch in terms of how he does the grading. One of the things that I've certainly come to appreciate is that students are not always necessarily able to appreciate the quality of the teaching at the time. That was the case in my own education. And so, in preparing this, we went back to some of our illustrious grads. For example, Hiro Fujita, who's gone on to build a successful company, Quality Electrodynamics. When Hiro heard about this, he told us how highly he thought of the graduate courses that he took from Ken, and particularly because of their rigor and high standards, which I think has carried over into all of his work, for example. In a slightly different vein, he had worked with my first PhD student, Evelyn Gates, now the director of the Cleveland Museum of Natural History, on the Majorana work. When she was finishing her thesis with me, Evelyn expressed a hope that she would be able to write the shortest thesis in the history of the department. When Ken heard of this, he expressed a equally succinct opinion that if so, it will also be the shortest defense. Now, I'd really like to turn in the 45 seconds or so that I have left to the period that I worked most closely with Ken, roughly from 1992 to 2000, and especially from 1992 to 96. And this was started probably January 2nd or January 3rd of 1992 when we started a long-distance collaboration with the eminent theorist Bjorkane on speculative phenomena that might be taking place in every high-energy collision at every accelerator that had been built up until then and not be observed. And that led to our work on the phenomenology of disoriented chiral condensates, basically in modern particle physics theory with spontaneous symmetry breaking. The vacuum really has bulk properties, and the question is could you detect or create sort of long wavelength fluctuations of this? That in turn led to, in probably June of that year, I first learned that there was an unused collision area at the Fermilab Tevatron, and so sent an email to one of our recent grads that was working there, Mike Martins, who, Mike, are you here? Maybe he's not. Oh, he's got lab. Okay, well, he's got an excuse. In any case, it turned out that that was the second, I was basically asked if he could get me the drawings for the collision area, and he thought this was an odd request for a string theorist to be asking for drawings. And in any case, it was the second request he'd gotten that week, another one being from an experimentalist at University of Michigan. So Ken and I got drawn in the next phase of basically theoretical support work for a more very aggressive design for a collider detector on an insanely short time scale, which the Physics Advisory Committee in Fermilab dismissed in December of that year, largely because I think they didn't have confidence in the motley crew, I believe was the phrase that they used, that was working on it. Fast forward to February, and I had this crazy idea for how we could strip it down to something that we could surely do. And, it's kind of crazy for a string theorist to be thinking about proposing a experiment. So the first person I went to was Ken. And Ken thought it was a fabulous idea. At least that's the way I remember it. So, with that in the way of moral support, we went to Tom Jenkins and Bill Fickinger, who said, yeah, we can do that and build it. And one thing led to another. And make it really short, the proposal we put together in a couple of weeks, delivered it April 1st, which was prescient in some fashions. And May 28th, we got approval to go in. And I think 2 days later, Ken and I were out there in Fermilab in a room, 30 feet underground, 6 inches of water in the floor, 100 degrees, 100% humidity, with about 10,000 cables with one end in the water and the other going through cable trays up to counting rooms. And we had to figure out which end downstairs was connected to which end upstairs. So in any case, Ken turned out to be sort of the consummate experimentalist, or at least theorist in an experiment. The question is what does a theorist do on an experiment? And the answer is anything that has to be done that you can't get an expert to do. And so, from shielding walls to, I remember you were the best solderer on some of the very fine work that we had to do on the wire chambers, and so we had a production run of that going. Monte Carlo simulations, theoretical developments, developing the statistical analysis of the data to tell what the signal was. I mean, just everything about the experiment Kim played an absolutely significant role in. And the reason for dwelling on that is a little bit is because in my mind, this ability to move swiftly and with agility and grace from the ethereal realms of theory to the nitty-gritty of installing an underfunded, understaffed experiment on an insanely aggressive timescale is an extraordinary measure of Ken's abilities as a physicist and his character as a human being. And I, for one, will always be enormously grateful for the opportunity I had to work with him, and it changed my life, and I think had actually a fairly significant impact on the field. Without that work, the experiment that I still get to spend a little bit of time on these days at the LHC, I think would not have come to pass. So this 3 or 4 minutes I've taken doesn't do justice to Ken's career, but hopefully gives you some flavor of really the deep, deep respect in which I hold him. Thanks. Happy birthday, Ken.
So we would like to hereby ask all of our honorees because this has been such a splendid occasion, to join us again in 10 years, to do this again. And in fact, it would be quite the coincidence, quite the happy coincidence, if Andrew and Claudia's baby comes just a couple weeks early, decides to be a physicist, and joins the faculty. We will have a 0-0 to join the 50s, 60s, and 80s we've celebrated today. So please let's give these, not only, yes. Oh, yeah.
Great idea.
A photo of her, yes, absolutely.
You guys
Yeah.
mind coming forward?
Okay. Well, let's do the applause first. And not only for these 9, but also in thanks to Phil Taylor and Bob Brown. And planning it so beautifully and carrying it out spectacularly. Thank you so much. Okay. And please, after the photos, join us in the hallway where there's a big birthday cake and other goodies waiting for you. Thank you.